I'm going to work through 7.3, the chapter review solutions. If you look at the right side of your screen again, you can see the problems that I'm grabbing from. Okay, starting with number 24. We're going to write these equations in logarithmic forms. Now remember how this works. The 6, get your vocabulary down, we call it a base. The 2, we call it an exponent, and then the 36 is like the solution to that thing. Here's how we do it in logarithmic form. We read these things as log. We say log base, and we say that number the base is. We log base of, whatever the thing we're asking equals, and it's going to be, the answer is the exponent that you're talking about. So in this case, it'll be log. What is your base? Your base is going to be 6. So put a 6 and like a tiny little subscript 6. Now, it's the log base of 36 is 2. So we always put the exponent at the end. We put the base over here. And here's what this means. What do you raise 6 to the power of to get 36? You raise it to the second to get 36. Okay? Now that you got that format, you should be able to do these other ones a lot quicker. Let's look at 25. 25, we have since we have 2 to the negative third power is equal to 0.125. Well, what's 2? 2 is your base. So you do log base 2 of 0.125 is equal to, you always put the exponent here, is equal to negative 3. This is your solution. Okay? Number 26. All right? Well, we have 3 to the third is 27. Now, this is 3 pops up twice, so in a way you can make a mistake and still get one like this. But this 3 is the one that's the base, in case you're curious. Now, log base 3 of 27 is 3. You raise 3 to the third to get 27. This is the logarithmic form. This thing right here is exponential form. So we're going from exponential form to logarithmic form. All right, let's look at 27. It's the last one like this. Again, we're getting the practice. 10 to the negative third is equal to 0.001. Okay, so, well, what's your base? Your base is 10, so you can just put the 10 down here. Log base 10 of 0.001 is equal to negative 3. But this is fine. This is the correct answer, but you could also do this. Because whenever you write just log without a base, the 10 is understood. You could also write log base 10, which is understood, 0.001, or 1,000th is the proper way to say that, equals negative 3. Both of these are correct. But please know, like we practice a lot, please know that whenever there's not a base, it's understood to be base 10. Okay, that's how we're flying through these. 28. Here we want to evaluate the logarithms. Now, I'm going to do it the quote-unquote proper way. Like say you're taking the SAT or practice SAT and you're not allowed to use a calculator on some of these. I'm going to show you how to do them without a calculator. Okay? Then I'll show you a way to confirm it in your calculator. All right, log base 2 of 64. All right, well, that means what? Remember, what's important is you know what the question asks. It's asking what power do you raise 2 to get 64. So let's do 2 times 2. Well, what's that? That's 4. Okay, multiply by 2 again. Okay, that's 8. Okay, multiply that by 2 again. That's 16. So we're not quite there. We're already at 2 to the 4th and we haven't got to 64. All right, multiply by another 2. You get 32. Oh, we're almost there. Just multiply by one more 2. You get 64. So 1, 2, 3, 4, 5, 6. If you take 2 to the 6, you get 64. So therefore, log base 2 of 64 must be 6. Now, in your calculator, here's a way. There's 2 ways you can do this. If you're allowed to use your calculator on a question like this, here's how one way you can do it. Now, the log button, unfortunately, let me do something that's not the right way. Let me try hitting log. If I just do log of 64, well, notice how it does not give me 6. Well, that's because this is log base 10. So we have to fix it. We can do something called the change of base formula, which works like this. You could take, and it doesn't matter what log button you hit. You could even hit this ln button, but I'll just hit log of 64. All right? And then I'm going to put that over log of 2. And then notice how, voila, you get 6. But this is the why it works. It's important that you understand the question it's asking. 2 to the what power gives you 64. But this answers for it. There's another way if you have an updated calculator. Hit math, scroll up, see where it says log base. And it actually lets you change the base right there. You don't have to use a change of base formula. But the reason why I want to show this to you is because I want you to remember that these are both the same thing. So I'm going to grab this, okay, and just put on, like, just kind of leave this in here so you can kind of look at it like, oh, these are equivalent. The change of base formula is another, it's here I'm changing from base 10 to base 2, but you could just, on updated calculators, type it in manually. Okay, now I'm going to do the rest of these. You know how to do it on your calculator now to at least confirm it, but I'm going to show you how easy these are to do by hand, because actually it takes me a longer time to type them in sometimes. All right, 29 log base 3 of 1/9. Now, I know that if you take 3 and raise it to the second power, you get 9, but a fraction, that's weird. Oh, wait. If I take 3 and I raise it to the negative power, that's how I get fractions. That's 1 over 3 squared. That's 1/9. So the answer to this is actually -2. Notice how quick I did that. Confirm it in your calculator if you want, but that's how you do these. 30. Let's do log. Wait, there's not a base there. That's weird. But I'm going to write this 0. Oh, that's so many zeros. It's sometimes hard to read the zeros. There's 0, 1, 2, 3, 4. Okay, 4. It looked like there were more than that. Well, 5 if you include this one, but I mean the ones between the decimal place. Wait, there's no base here. Oh, wait. What is understood? What base goes there? It's a 10. This is log. Pardon my sloppy G's. Log base 10. That means 10 to what power gives you this? Well, if you remember when you raise to a negative exponent, it moves the decimal to like the other side. Notice how I moved this 1, 2, 3, 4, 5 times. This is 10 to the negative fifth. That's what 0.00001 is. Or, let's see, that's 10th, 100th, 1000th, 10,000. This is 100,000th. You can confirm. In fact, I'm a little nervous here. It's like, wait, is that really how you do this? Sure, let's confirm it. And instead of me you can type the log thing, but I'm going to confirm it this way. I'm going to do a guess and check way. 10 to the negative fifth. Let's see. Do I get, it's put in scientific notation. I don't want it to do that. Ah, that's a bummer. It just kind of does it. So let's just do this. Let's use just log base 10. Base 10 is understood. 1, 2, 3, 4. Zeros. You put a 1. I actually don't have to close parentheses, and I sure do get -5. But again, instinctively, I was able to do it really easy by hand. Again, these are not hard to do by hand. All right, 31 log base 2 of 1. This seems difficult, but it's not. Here's what it's asking. The question it's asking is important for you to remember. Okay, so I'm going to actually type out the question just so you can see it. What power of 2 is equal to 1? Okay, that's the question it's asking. Well, I know that if you raise any number to 0, you get 1. So 2 to the 0 is 1. So guess what? This answer is 0. And if you did it in your calculator, you get the same thing. Next one, 32. Y is equal to log base 3 of x. But here's the instructions. We want to graph the logarithmic function. All right. I am going to graph these things. Okay. I could make a table out of this. But what I'm going to do is I'm just going to graph this in my calculator, and just because I really just want to get an idea of what these look like. And I'm going to show you something. I'm going to do more than what they asked me to do when I graph these. I'm not just going to graph them, but I'm going to graph something that is the inverse function of these. So let me show you what that looks like. So we got log base 3 of x. I'm going to go to y equals. Clear this out here. And I'm going to go to math. I'm going to option this right here, log base 3 of x. And I'm going to graph in the standard window. Zoom 6. Here's what that graph looks like. Notice how whenever you hit, if I go to trace here, notice how in that graph, when my x value is 1, notice how when x value is 1, you got y is this number right here. So let me just calculate that. Let me do second calc. Let me just try to get some value. So my x value when x is 1. Okay, I got a y value of 0. Okay, so I could plot points that way if I had to plot this by hand, but I wouldn't want you to graph it by hand. I just want you to get an idea of what it looks like. Let me go back to second calc. Let's see when I have an x value of 2. Okay, it's like, oh, it's just some weird decimal. But here's what's important. Logarithmic functions, notice how they hug the negative y-axis. You can't see it clearly, but it goes down right here. That's called an asymptote, okay? So these things are, this thing is an asymptote. So here's what it's going to look like. Every logarithmic function, right, is going to, it's going to like spike down right here. That's what that function looks like. All right. Let's just roughly sketch those other ones. 33. Okay, we have log base x plus 2. Log base 10 of x plus 2. So if I take y equals log of x plus 2, that's really log of 10. All right, this time I'm going to show it to you in Desmos. Okay? So I'm going to grab a little Desmos window, and I'm going to graph really quickly. Let me actually review before I do that. Let me do log. Oh, I don't know how to do log base in Desmos, but I do know how to do this. Let me see, log 3. Nah, I can do it as a fraction though. If you look at the y equals, I can do log of 3. So I want to do log of x over log of 3. This is that, using the change of base formula, this is that one that I graphed for. And here's what I want to show you. I want to show you that this is the inverse function of 3. Oops, don't want to do there. This is the inverse function of 3 to the power of x. So I'm going to go right here, 3 to the power of x. Notice how those are inverse functions. They're like mirrors of each other. That's really all that I want you to know as far as graphing those, that they're inverse functions of exponential functions. Okay? But if I grab log base x of 2, okay, here's basically what this thing looks like. You confirm these on your calculator. What I want you to know is that what the plus 2 does, it shifts it up by 2. So it is still going to go through, like, normally it would go to the point 1, 0, but instead it'll be like 2 points up, and this one will still have that same basic shape, but it's shifted up by 2. It's still not going to hit that axis there. Let's look at 34. This one is going to be 3 log base 2 of x. Okay? Now this one is going to be the log, like I'm going to do this instead. I'm going to graph 2 to the x. So the function 2 to the x looks like this. So the function log base 2 of x would look like this. It's a reflection of that. But here's the thing. It's 3. It's multiplied by 3, so everything, it climbs a little faster. So instead, it's going to be like 3 times as tall everywhere it goes. All right. Let me do 35. Y equals log base 5 of x plus 1. Here's really what I want you to know. So I want you to know that this is a vertical stretch, but this thing right here, well, let's talk about what just the pieces are. What does the plus 1 do? That moves it 1 to the left of the default log function. So instead of the function doing like this, it would actually do more like, it would do like that. So this would be that graph right here, and you could confirm that by graphing your calculator if you want. All right, don't worry too much about like graphing it. It's really just to show that they're like inverses. I don't want you to ever have to worry about graphing that by hand. It's not really a a priority, okay? Now, how does the graph of each function compare to the graph of the parent function? This is what I was talking about previous. This is what I really want you to focus on. All right, your parent function, so we have y, your function that we have right here, 3 log base 4 of x plus 1. The parent function of that is just log base 4 of x. Well, let's see what these things do. All right, plus 1, what does that do? That moves it 1 to the left. Okay, now what does the 3 do? The 3 is it stretches it. It's a vertical stretch by a factor of 3. You can think of it almost like a slope. That's what that is. Now let's do 37. 37, this is y equals negative. Now this is ln of x plus 2. Here's what that stands for. That stands for natural log. But, by the way, ln of x is log base e of x. But here's what I want you to focus on. What does the negative do? We talked about this in an earlier video. This reflects the function. It reflects it across the x-axis. What does the plus 2 do? This moves it 2 up. Okay, vertical shift, that's a reflect across the x-axis. That's it for this section.